In this lesson, we're going to learn about the derivative basics. So it's to recognize the meaning of the tangent to a curve at a point, calculate the slope of a tangent line, identify the derivative as a limit of a difference quotient, and calculate the derivative of a given function at a point. So these are the learning outcomes. And we've been talking for a while now about derivatives and tangent lines, and I've been making the connection, trying to make the connection about the derivative is the tangent, or the slope of the tangent line, I should say. So just to kind of review, we talked before, we had that preview of calculus that addressed this, but m being the slope of the secant line is f of x minus f of a over x minus a, and for some point a and some other point x, which is a certain number of units away. And then we have another way to consider the same thing. If your x was instead an a plus h, if we can make that substitution, you end up with an a plus h minus a, and those a's subtract out, leaving you an h down below. And in the numerator, you have f of a plus h minus f of a over h. And this is your difference quotient. So let me continue on this. Definition, let f be the function defined by the interval I containing a. If x not equal to a is in the interval I, then q equals f of x minus f of a over x minus a is a difference quotient, but typically the one that we call the difference quotient is the following one, that's the f of a plus h minus f of a all over h. And the idea is you have your secant line and you want to try to bring those points together. So we're looking at it with a limit as that h, that difference here, this h, becomes 0. So it becomes a single line. It goes from a secant line to a tangent line. As you see here, these points get closer and closer until you have that single point there. And now we have a tangent line. Same thing in this setting, is we're looking for that point, that slope of that tangent line. And if you zoom in real big, at some point for a while there, they may coincide, or look like they coincide. They only touch at one spot, but they may look like they coincide. So let f of x be a function defined in an open interval containing a. The tangent line to f of x at a is a line passing through the point a f of a and has the slope. So this gives us our slope. Okay. And another is using the difference quotient, where we've replaced the x with a plus h. So these are the two ways to get that slope. And this is doing the limit. Now I want to be clear. We're going to do this section and another one we do the derivative as a function. Those are both going to be using this slope, this limit process. And then we're going to get into the shortcuts, and you're going to be really happy about that. Trust me. So in this point, what we're talking about is when you evaluate something with like an f of h plus 1, how that goes in there, that this h plus 1 is going to go in place of the x, so that f of h plus 1 is going to be 4 times that h plus 1 plus 1. So 4h plus 4 plus 1, or 4h plus 5. And just recall the point slope form of a line, y minus y1 equals m times x minus x1. You've seen this before in probably the equivalent of Math 96. If you've taken Math 96 or like your Algebra 2 class, maybe even your Algebra 1 class. So this is nothing new, but this is a tool we use to be able to come up with the equation of the tangent line. We're given the slope, we find the slope, and we have a point, we can put this all together. So find the equation of the tangent line to to the graph of f of x equals x squared at x equals 3. So our f of 3 is going to be 3 squared, which is 9. So our point is going to be 3, 9 that we're working with. And now we have to find that slope. So our slope, I'm going to put slope of the tangent line is going to be that f of 3 minus, f of x minus f of 3 over x minus 3. And I forgot a critical part of this. Let me erase that. I'm going to write my limit as x approaches 3. And this is the slope. Okay, so let's do this work. So we're looking for the limit as x approaches 3 of, now our f of x is x squared. Our f of 3 is 9 over x minus 3. So that's going to be the limit as x approaches 3 of x plus 3 times x minus 3 over x minus 3. And these x minus 3's divide out. This leaves us with the limit as x approaches 3 of x plus 3, which is 6. And now that's the slope. And now we have a slope and a point. So y minus y1 is m times x minus x1. So y minus our y1 is the 9 equals m, which is 6 times x minus 3. So y minus 9 equals 6x minus 18. And then we add the 9. So y equals 6x minus 9. That's it. Hope that makes sense. Go ahead and pause if you need to. So now they want us to use the second definition, that what I like to call the difference quotient. I know they're both consider that, but so in this case, we're looking at the limit, and we're just going to find the slope now. We already know what the equation is going to be. The limit as h approaches 0 of f of a, in this case, is 3. 3 plus h minus f of 3 all over h. So this is going to be the limit as h approaches 0 of 3 plus h squared minus, we know what f of 3 is, it's 9 already, we did that one earlier, all over h. So we're looking for the limit as h goes to 0 of 9 plus 6h plus h squared minus the 9 all over h. And if you're not sure how that happened, look up your binomial expansion. A plus b squared equals a squared plus 2ab plus b squared. So these 9's, by the way, we have a 9 minus 9, so those will subtract out. And we're left with the limit as h approaches 0 of 6h plus h squared over h. And the h would divide out then, so it's the limit as h approaches 0 of 6 plus h, which would be 6. Same thing we had in the last one. Okay, let's look at this next one. It's a little more interesting. It is find the equation of the line tangent to the graph at x equals 2. So my f of 2 is 1 over 2. So we have the point 2, 1/2. Now we want to find the slope. And we really have, either method is okay to use. It doesn't really matter. So I'm trying to think what might be better. I don't know. I'm going to go with the difference quotient with the h. So limit as h goes to 0 of f of 2 plus h minus f of 2 all over h. So that's going to be, I'll get enough space there, limit as h goes to 0 of 1 over 2 plus h minus 1 over 2 all over h. And we want to combine these, so we need the common denominator. So I'm going to multiply the first one by 2 over 2, and the second one by 2 plus h over 2 plus h. And what do we have? We have the limit as h goes to 0 of 1 over, not 1, it's 2. It's 2 over 2 times 2 plus h, then minus 2 plus h over 2 times 2 plus h. So we got the common denominator all over h. So that's going to be the limit as h goes to 0 of 2 minus h. I distribute that negative over 2 times 2 plus h over h. So that's going to become the limit as h goes to 0. 2 minus 2 is nothing, it's 0. So we have minus h on top. The 2 times 2 plus h. I'm trying not to run out of the boundary. Wait, I can just do this, can't I? Yeah, look at that. And then times, that h is down below, times 1 over h. So that will divide out with this h, leaves a negative 1 on top. Excuse me. So now we have the limit as h goes to 0 of negative 1 over 2 times 2 plus h. Now that that's a plus and not a minus, if h goes to 0, we would have negative 1 over, I guess it wasn't something else, but negative 1 over 2 times 2 plus 0, which is negative 1 over 4. And that's our slope. That's the slope we're looking for. Now, I can go back to this. M equals negative 1/4. So we have y minus, our y1 is 1/2, is negative 1/4 times x minus 2. So y minus 1/2 is negative 1/4 x minus 1/4 times 2, negative 2 is plus 2/4. And I'm going to add 1/2 to both sides. So y, that was not a very good drawing. Get rid of that, get rid of that. So y equals negative 1/4 x. And so 2/4 is 1/2. 1/2 plus 1/2 is 1. There is your equation of the tangent line at the point 2, 1/2. Pretty cool, huh? I know dealing with fractions, especially complex fractions, can be more than overwhelming. But that's the strategy there, is to multiply by, get the common denominator, combine those two terms in the numerator, and go on from there. Feel free to pause. Okay, moving on. Now we have f of x equals the square root of x. So they're just asking us to find the slope of the tangent line. The last one, do they want us to find the line? They wanted the equation line. So now we just have to find the slope. That's about 2/3 of the work, so that's cool. F of 4 is the square root of 4, which is 2. So the point is 4 comma 2, although it doesn't really matter because we're just trying to find the just the slope. So draw that line. Let's look for the limit as h goes to 0 of f of a plus h, so it's 4 plus h minus f of 4 all over h. So that's going to be the limit as h goes to 0 of, so 4 plus h goes under the radical, the square root of 4 plus h minus, and f of 4 is 2 over h. So one way to approach this is to multiply by the conjugate, which is going to be the square root of 4 plus h plus 2 over the square root of 4 plus h plus 2. This is the one where the plus makes the difference. So in the numerator, we're basing off of that fun-filled principle, a minus b times a plus b is a squared minus b squared. So sum and difference. I know that people still forget this, so I'm trying to help you remember that. The limit as h goes to 0, what we have is a something minus something else, something plus something else. So that's our a minus b, a plus b. So this can be that radical squared. So we're going to have the 4 plus h minus, and then the 2 gets squared, 4, over h times the square root of 4 plus h plus 2. So you might see it now. Those 4's are going to go away. And that leaves us with the limit as h goes to 0, h over h times the square root of 4 plus h. And I'm kind of falling out of the zone. Now those h's will divide out. And we end up with the limit as h goes to 0 of 1 over the square root of 4 plus h. I forgot my plus 2. Plus 2. So as h goes to 0, that becomes 1 over the square root of 4 plus 0 plus 2. So it's 1/4. Okay, pretty cool, huh? Again, I'm going to show you some tricks pretty soon, and I can't wait to do that because you're going to love it. That'll make this go a lot faster. But I hope you understand this limit process with what's going on. As h becomes infinitely small, and so you're able to get the slope at that particular point. Okay, moving on. Got a few more pages to go through here. A few more examples. So find the slope of this, and then they want the equation. So we've been seeing this type of thing quite a bit. Let's see here. We're given a point, so we have 1, 7. We know that we know what things are. So let's go with the limit. I'm going to go with the old school one. As x goes to 1 of 9x minus 2x squared. I'm doing the f of x minus f of a. So 9x minus 2x squared minus 7 over x minus 1. So the idea behind this is hopefully it factors. Well, it better factor, otherwise we're kind of in trouble. What we have is a negative 2x squared plus 9x plus 7 over x minus 1. I'm immortalizing my dog's heavy breathing. I have a very geriatric dog, so I apologize, but it's a good dog. I don't know if you can hear this or not. I'm immortalizing it in my videos here. Limit as x approaches 1. Let me think about this. If I factor the negative out, I end up with a 2x squared. Oh, that was a minus 7. 2x squared minus 9x plus 7 over x minus 1. So I'm going to just proceed from the assumption that this could be written as negative of, is x minus 1 a factor, then the other one would be a 2x. 2x should be minus 7, right? So 2x times negative 1 is negative 2x. Negative 7 times x is negative 7x. That gives us our negative 9x. That works. And so again, I built that factoring. I could have just done the AC technique, but I was pretty sure that x minus 1 is going to be a factor. So these would divide out. And we end up with the limit as x approaches 1 of the negative of 2x minus 7. Now we can plug that in. We have the negative of 2 times 1 minus 7, which is the negative of 2 minus 7, which is the negative of negative 5. So I get 5. Okay. Okay, so now we have the slope, we have the point, so m is 5. It's in the dead zone. M is 5. So we have y minus our y1 is 7 equals 5 times x minus our x1 is 1. So y minus 7 is 5x minus 5. Adding 7 to both sides, y equals 5x plus 2. And that's it. Let's go on. Let f of x be a function defined in an open interval containing a. The derivative of the function f of x at a denoted by f prime of a, that's a certain notation type, is defined by f prime of a equals the limit as x approaches a of f of x minus f of a over x minus a. Also, doing the difference quotient based on h, f of prime of a equals limit as h goes to 0 of f of a plus h minus f of a over h. Now, when we get into finding the derivative as a function, those a's stay as x's, so we don't get concrete numbers, we get variables in there still. So it says use a table to estimate f prime of 3 using the first definition above. So in this problem, they're asking us to find, so first of all, f of 3, so f of 3 is 3 squared, which is 9. So it's going to be the limit as x approaches 3 of f of x minus f of 3 over x minus 3 is going to be the limit as x approaches 3 of x squared minus 9 over x minus 3. Now we already solved this using algebra. Now they want us to use a like Desmos, so hang on a second. So if we look at this, I put it in Desmos here. Y equals x squared minus 9 over x minus 3. Okay, and it makes a line because we know if we were to factor it out, it ends up being x plus 3. But we'd have a hole up here at, when x is 3, we have that hole there because of the x minus 3 in the denominator in the original version. And if I zoom in, these dots are reflective of the graph here, of the table, excuse me. So that's, Desmos is really good about putting those in. So we see a trend of points occurring, and we can see where they're going towards. We see they're going towards the 6 here as x approaches 3 from either side, and we see it in the table. On both sides is going to be the 6. So that leads us to conclude, based off the table, which, I mean, again, I'm going to say we already did this 2 different ways algebraically. So this is kind of stepping back a little bit. And that's that. We found the derivative at the point. Okay, let's try another one here. Now they want us to do the second definition of the derivative. So we're going to be looking at the limit as as h approaches 0 of f of 3 plus h minus f of 3 all over h. So that's going to be the limit as h approaches 0 of, so that's 3 plus h squared minus 9 over h. So that's the limit as h goes to 0 of 9 plus 6h plus h squared minus 9. So check that out. Those 9s end up going away. And this is not a coincidence that what you end up with in the numerator should all have h as a factor, so we can divide out the h in the denominator. We end up with the limit as h goes to 0 of 6h plus h squared over h. The h's divide out, so you have the limit as h goes to 0. I guess I'm going too far, aren't I? So someone stop me now. Okay, so I'm going to stop myself there because I think we're supposed to go no further than this. We're probably supposed to be back here at this point, and put that in and see what happens as h gets to be 0. And in this, when I put this in here, I don't think I can put it as an h. I'll see what I can do for Desmos. I feel like I have to put it as an x. But let's try it. Another table. It's not going to show up properly in the values. It's going to end up showing up over here around the x-axis. So, because we're talking about those h's. Well, let me say h here. Let's see what it does. I don't know. Maybe this will work, maybe not. So it's going to be 3 minus h. And we're going to square that. And then we're going to minus 9. And then we're going to divide this whole thing by h. So we're talking about as h gets closer to 0. So let's say we go from negative 0.1. Hey, look at that. Negative 0.01. Negative 0.001. Oh, here's my mistake. That should be a plus in here. There. Oh, look at that. Coming out to be the values like we saw before. Negative 0.001. So we're getting closer and closer to 0. On the other side, 0.0001. Then 0.001. Then 0.01. And then 0.1. And we get the same type of values that we saw in the previous table. And here they are. Okay, that's cool. Okay, let's keep on trucking. So for f of x equals 3x squared minus 4x plus 1, find f prime of 2 by using the first definition. So our f of 2 is going to be 3 times 2 squared minus 4 times 2 plus 1. So that's 3 times, that's 4, so it's 12 minus 8 plus 1, so I believe that's 5. So we're using the first definition, limit as x approaches 2 of f of x minus f of 2 all over x minus 2. So I'm assuming this polynomial will have x minus 2 as a factor. And let's see, we would have the limit as x approaches 2 of 3x squared minus 4x plus 1, and then f of 2 is 5, so minus 5 all over x minus 2. So we have the limit as x approaches 2 of 3x squared minus 4x minus 4 over x minus 2. So that'll be the limit as x approaches 2 of, so I know x minus 2 is a factor in the denominator. Let's say it's a factor in the numerator and see if this works out. I'd have to have a 3x and then probably have a plus 2, because plus 2 times minus 2 is a minus 4. And look what that does work out. So I want to point out I did not spend time doing AC technique. I figured x minus 2 must be a factor. If that didn't work out, I had to figure something else out, but I'm pretty sure it's always going to work out. So don't mark my words on that. So the limit as x goes to 2 of the quantity 3x plus 2 is going to be 3 times 2 plus 2, which is 8, right? Now, if that wasn't fun enough, we could do the same problem using the second approach. So we're going to do the limit as h goes to 0 of f of 2 plus h, let me draw the line there, minus f of 2 all over h. So I'm going to save myself some space over there and do my f of 2 plus h over here That's going to be 3 times 2 plus h squared minus 4 times 2 plus h plus 1. So 3 times, that's 4 plus 4h plus h squared minus 8 minus 4h plus 1. So that's 12 plus 12h plus 3h squared minus 8 minus 4h plus 1. So I'm going to start collecting these terms. 3h squared, I see that. I see a 12h minus 4h, so that's going to be a plus an 8h. And then I see a 12 minus 8 is 4, plus 1 is 5. So we end up with the limit as h goes to 0 of 3h squared minus 8h plus 5, and then minus, what was f of 2? No, that's 5. Well, that's convenient. All over h. So we have the limit as h goes to 0 of 3h squared minus 8h over h. And the h's divide out. Is that a minus? That's a plus 8. Okay. Okay, good. So that's going to be the limit as h goes to 0 of 3h plus 8, which will become just 8. Hey, it's the same thing. Are we surprised? No, we're not. Okay. Moving on. For f of x equals x squared plus 3x plus 2, find f prime of 1. So what is our f of 1? That's going to be 1 squared plus 3 times 1 plus 2. I'm getting 6 out of that. So I don't know which way you want to go with it. Let's go with the first one. Limit as x approaches 1 of f of x minus f of 1 over x minus 1. I wonder if people like the other one because they don't have to factor as much. So we end up with the limit as x approaches 1 of x squared plus 3x plus 2 minus 6 over x minus 1. So that's the limit as x approaches 1 of x squared minus 3x minus 4 over x minus 1. The limit as x approaches 1 of x minus 4 times x plus 1 over x. That's next minus 1. Helps to carry the right signs through. That's a plus 3x here. So that changes things slightly. And I'll just erase okay. It's x plus 4, x minus 1 over x minus 1. So the x minus 1 terms will divide out. And we have the limit as x approaches 1 of x plus 4. So that's 1 plus 4, which is 5. Okay, cool stuff. Moving along. This is going to be a long video already. There's another video for you to watch if you want to. And this is our last problem of this section. Not of this part of the section. So let f of x equals 2x squared. Find f prime of 2 using the limit definition of the derivative. This value will be the slope of the tangent line. Okay, we know that. So again, the process goes. F of 2 is 2 times 2 squared, which is 2 times 4, which is 8, right? So let's do the h one. Limit as h goes to 0 of f of 2 plus h minus f of 2 all over h. So that's going to be the limit as h goes to 0 of 2 times 2 plus h squared minus the 8 over h. So it's the limit as h goes to 0 of 2 times, that's going to be 4 plus 4h plus h squared. It's real important to get comfortable with the binomial expansions. Minus 8 over 8 is the limit as h goes to 0 of 8 plus 8h plus 2h squared minus 8 all over h. So what happens? The 8's go away. Anything without an h is going to go away. And we have the limit as h goes to 0 of 8h plus 2h squared over h, which gives us the limit as h goes to 0 of 8 plus 2h. And as h goes to 0, this becomes 8. So that's your slope. Okay, I believe that's it for this section. That's a lot of stuff, this section. And then we have another one. As part of this is the velocities, instantaneous velocities. So you'll catch that in the next video. Okay, I'll see you guys.